Good evening, friends. Today we are going to learn ultraviolet visible spectroscopy. The chapter belongs to TYBSc Analytical Chemistry, semester 5, and it is credit based 2019 pattern. Firstly, ultraviolet visible spectroscopy. Here, two words UV and visible spectroscopy is mentioned. Ultraviolet means in Marathi we can say जांभूळ किरणे and visible radiation means दृश्य किरणे. The combination of two spectroscopy, but here the length or the range of this ultraviolet visible radiation lies in the range of 200 to 800 nanometer in the electromagnetic radiation. Here wavelength pattern is given, and along with electromagnetic radiation pattern is given. Properties of the electromagnetic radiation is also given. Now here electromagnetic radiation is nothing but it is a bundles of energy. Electromagnetic radiation is a form of energy that transmits through a space with a very high velocity. The properties of the electromagnetic radiation are given as under on this page. Now here if you see the wavelength in this figure, the red region, or you can say the red zigzag line is given, that is electromagnetic radiation, and this electromagnetic radiation here comes from present in the universe, and they are traveling to and fro everywhere in the different rays, in the form of different rays. The wavelength is given, frequency is given, amplitude is given, period is given, and the properties, that is the velocity, is given. These are the 5 properties of electromagnetic radiation. Now wavelength is mostly considered as a first property of electromagnetic radiation. The wavelength is the linear distance between the successive maxima, that is regarded as a crest, or minima, that is regarded as a trough. It is the distance traveled during a complete cycle. The frequency is there. Frequency is the number of oscillations of the electromagnetic field vector per unit time. It is also defined as the number of cycles passing through a fixed point in the 1 second. Period is also the third property of electromagnetic radiation. The period of the wave is the time taken in second that is required for successive maxima or minima to pass a point in a space. Next properties of electromagnetic radiation is amplitude. It is a vector quantity. Now the quantity is nothing but these are the two types of the quantities, mostly vector and the another is scalar one. Now the out of that, it is amplitude is regarded as a vector quantity and provides a measure of the electric field strength at a maximum point in a wave. Now if we see the pattern of this electromagnetic radiation, now here the red line indicates the traveling region of the electromagnetic radiation. Now the wavelength is nothing but the, according to definition, here crest and trough is given. Crest is nothing but the height of this electromagnetic radiation, and trough is nothing but the depth of the electromagnetic radiation as given as at the arrow bottom of the wavelength name. Next one, if you see the frequency is nothing but the number of oscillations passing through a particular time per unit time. Again, period is there. The period of a wave is is the time taken in second that is required for successive maxima. That means the successive maxima passes with a particular time which is in second, and that is nothing but the period of the electromagnetic radiation. Next one is amplitude. Again, I will repeat the same definitions for student. It is a vector quantity and provides a measure of the electric field strength at a maximum point in a wave. So that is nothing but the you can say the properties of the electromagnetic radiation. Now this is the page taken for reference from the TYBSc textbook. Now this is nothing but the spectrum of the electromagnetic radiation. As before page, here we studied the properties of the electromagnetic radiation. The electromagnetic spectrum is divided into different types of the radiation again. Gamma radiation, X-rays, UV, IR, microwave, radio waves. Now all have the same unit lambda, that is expressed in micrometer. And see, if you see here below particular one, violet to red spectrum is also given in the range of 400 nanometer to 780 nanometer. So that is nothing but the region of the ultraviolet and visible spectroscopy. You can say mostly visible spectroscopy, that is 400 to 780 nanometer, because ultraviolet radiation have the wavelength in the range of 200 to 400 nanometer. Now the terminology is used in the absorption measurement. If you see, this is the some definitions included in this chapter. Radiant energy. It is the energy transmitted as electromagnetic radiation. Now the electromagnetic radiation possesses some energy, and that energy is regarded as a radiant energy. It is characterized by wavelength, that is lambda, and frequency. So the characteristics of the radiant energy is expressed in terms of wavelength and frequency. The relationship between the wavelength and frequency is given, that is lambda is equal to C upon lambda again. So that is nothing but the relationship between the wavelength and frequency. Next definition is radiant power. After radiant energy, radiant power is given. It was formerly known as intensity. So intensity of the electromagnetic radiation is nothing but the radiant power, and the definition is energy per unit time. So power is nothing but the energy per unit time. But if you measure the electromagnetic radiation, the definition should be modified in terms of electromagnetic radiation having whatever the energy is associated with them. So that should be divided by per unit time. Then it is regarded as a radiant power. Third definition is transmittance. It is a fraction of the incident light transmitted by sample. It is usually expressed as a percentage transmittance. So T is equal to IT upon I0, or percentage of T is equal to IT upon I0 into 100. Next definition is absorbance. It was formerly known as optical density. So optical density is nothing but another name for absorbance or excitation. So optical density has abbreviation OD, that is optical density, and excitation has abbreviation, that is E, and absorbance has a abbreviation, that is A. The absorbance is the logarithm to the base 10 of the reciprocal of transmittance T, where pure solvent is a reference material. So A is equal to log 1 upon T, or A is equal to minus log of T. So that 1 upon T is 1 upon, whatever the 1 upon is there, 1 upon T, that should be absorbed with negative symbol, so minus log of T. So there are the two relationships of the absorbance, but they are synonymous of each other. A is equal to log of 1 upon T, or A is equal to minus log of T. Next one is absorptivity. So absorptivity has an abbreviation A. It was formerly known as the excitation coefficient. Absorptivity is defined as the ratio of the absorbance to the product of optical path B and the concentration of the sample. So concentration is expressed in terms of mole per liter. So A is equal to small a is equal to capital A upon B into C. So that is nothing but the absorptivity, molar absorptivity. So epsilon is nothing but a molar absorptivity. Symbol of molar absorptivity is epsilon. It is a formula known as a molar extinction coefficient or molar absorption coefficient. Molar absorptivity is the product of absorptivity and molecular weight of the material. So if we multiply the absorptivity by molecular weight, we get molar absorptivity. So epsilon is equal to A into small a into m. Next one is path length. Path length is nothing but the internal thickness, diameter of the cell in which the test sample is taken. So it is denoted by the symbol B. So a cell of the material is made up of glass or quartz. So the path length is nothing but the you can say diameter of that particular sample, or you can say the sample cell or reference cell which is taken for the experiment. Now these are the nothing but the particular definitions or terminologies used in the absorption measurement, along with the properties of the electromagnetic radiation. So there are the 4 or 5 properties of the electromagnetic radiation we have already studied, and these are the definitions. So with this content, I conclude this lecture. Thank you for listening. We will again come across with some particular content of this chapter. Thank you very much.